In this example, we are going to find the volume that's created by taking the area that's bounded by these three curves and then rotate it about the x-axis. So the area that is bounded is this area here that I'm highlighting in yellow. And when we look at this purple line right here, the horizontal line, is the line y is equal to 6. This vertical line here is the line x is equal to 5. And then this green curve here is equal to f of x is equal to 1 over x. Now, when we rotate this about the x-axis, we are going to get a picture that looks something like this. Let's see if I can draw this nicely. So that's this part here when it rotates. Then this curve right here, the 1 over x, is going to cause a space in the middle when we rotate it. It's going to look similar to a cylinder, but because of this curve right here, there's going to be a dip in the middle. This is where the x-axis comes through. X-axis. Hopefully this helps you picture what's going on. So when we rotate it, this is going to be the picture we have. And so because we have this cavity here, it's empty space, rather than use the disc method, we're going to have to use the washer method because we have that hole in the middle. So when we create our slices, we're going to have that hole. So imagine we're slicing it. Let me see. Imagine we slice it right through here. This is going to be what the cross section looks like. So because of this hole or this cavity, you have to use the washer method. So by finding the area of this washer and then integrating it over the interval that we're looking at, and we'll get to that in a second, that's going to give us the volume. So first, let's figure out the area of the washer. When we make the slice from the center out, this is just going to be a radius of 6. Because this line right here, y equals 6, is going to remain constant. So when I come from the center out, that radius is always going to be 6. Now, for this cavity in the middle, let me use a different color. This radius of the smaller inner circle is going to be the radius 1 over x. So if I imagine that I'm making a slice this way, that gap in the middle is going to be based on the height or the value of the function 1 over x. So when we find the area of a washer, we need to take the area of the bigger circle, and then we need to subtract out the area of that inner circle because that's a hole. So we're going to integrate this by taking the area of the big circle minus the area of the smaller circle. The area of the big circle is pi r squared, and the r is 6. So we're going to have pi and then 6 squared. And then we're going to subtract the area of the inner circle, which is really a hole. We're going to take pi, and then we're going to take 1 over x, that's the radius, and square it. And then we have dx. Now we need to find the interval in which we're integrating over. So this point right here is the point of intersection. It's really close to the y-axis. When we come down here, that's going to be our value for x, and then we're going from whatever this value of x is up to 5. To find this value of x, we just need to find the intersection of the function 1 over x and y equals 6, which would be 1/6. So this is what we want to calculate in order to find the volume of that object when we rotate this area around the x-axis.